Hey everyone, welcome to assignment 61, Graphing Rationals Review. Show your work and answers on separate piece of paper. Great. 1. How do you know if you have a hole in the graph? If a factor in the numerator can cancel a factor in the denominator. If we got that situation, 2x plus 1, x minus 4, x minus 4, 3x plus 5. Kink, kink, x equals 4 is a hole. Okay, 2. Is it okay to cross horizontal asymptotes? What about vertical ones? Yes, for horizontal, no for vertical. 3. When trying to figure out horizontal asymptotes, what are the 3 different situations you need to think about? Well, if the degree of the numerator is smaller than the degree of the denominator, then y equals 0. If the degree of the numerator equals the degree of the denominator, then y equals the ratio of leading coefficients. So if I've got 3x plus 1 over 5x minus 7, the degrees are the same, I look at the ratio of leading coefficients and say y equals 3/5 is my horizontal asymptote. But that was only the second case. We need a third one, right? So our third case is if the degree of the numerator is in fact bigger than the degree of the denominator, we're going to do some long division to find a slant asymptote. Okay. 4. What's the best strategy to complete the graph after you have labeled any intercepts and asymptotes on the graph and they're still unsure? Oh, well, isn't that just the test a point thing? Like, if I have x minus 2, x plus 1, and I think about graphing this, in fact, let's graph this one. I see an x-intercept at -6. I see a y-intercept at 6 over -2, which is -3. A vertical asymptote at x equals 2. That comes from setting the bottom equal to 0. And the horizontal asymptote, because the degrees are the same, I'm just looking at the ratio of leading coefficients, and I have y equals 1. So vertical asymptote at 2, horizontal asymptote at y equals 1. We've got -6 for our x-intercept. Our y-intercept is -3. And I've plotted what I know. But I know that there's not only stuff to the left of the vertical asymptote, there's also stuff over here. And so what's the best strategy to complete this graph? Well, the thing I would suggest is that you plot some test points. My answer to problem number 4 is plot additional test points as needed. So if I plug a 3 in here, I get 9 over 1, which is 9, and 9 is bigger than 1. So my graph goes up here, 3, 9. All right. Well, let's get to this graphing then. I like to think at this point you're warmed up and ready to go. By the way, the graph I just drew was the graph for number 5. 6. 4 over 2 minus x. Okay, so a lot of students really stress about this. Set the denominator equal to 0. No, 4 does not equal 0, so there are no x-intercepts. And no, you didn't do anything wrong. There just aren't any x-intercepts. If I plug in a 0 for x, I get 4 over 2, or a y-intercept, 4 over 2, which is 2. Vertical asymptote at x equals 2. And horizontal asymptote. Well, the degree here is 0. The degree on the bottom is 1. Since the degree up here is smaller than this degree, we have y equals 0. Okay, so there's x equals 2. There's y equals 0. We've got a y-intercept of positive 2 and no x-intercepts. Well, I feel like that's pretty reasonable. And if you're not sure, you could always plot another point over here. But here on this side, I definitely need to put in another point, like 3. 2 minus 3, well, that's negative 1. 4 over negative 1 is negative 4. And so I think my graph goes like that, with 3, negative 4. Okay, there's 6. What about 7? 7. F of x is 3x minus 4 over 2x plus 1. X-intercept, 4/3. Y-intercept, negative 4. Vertical asymptote, negative 1/2. And horizontal asymptote. Since the degrees are the same, I look at the ratio of leading coefficients. So let's graph what we've got. Vertical asymptote at negative 1/2. Y-intercept of negative 4. X-intercept of 4/3. The horizontal asymptote of 3/2. I connect the dots and bend to the asymptotes. But there's a little bit more to this graph, something on both sides of the vertical asymptote. So I'm going to plug in negative 1 here, because this is negative 1/2. Negative 1 times 3 is negative 3 minus 4 is negative 7. Negative 1 times 2 is negative 2 plus 1 is negative 1. Hey, look at that, I get 7. At this point, my y value is 7. This line is 1.5. 7 must be above. So, negative 1, positive 7. And we want to bend to the asymptotes. And that one goes there. Okay. All right. How about number 8? Number 8, x over x squared plus 9. All right. What's different about this one? Well, it has an x-intercept at 0. If I plug a 0 in for the x's, I get 0 over 9. 0 divided by 9. 0 pizzas eaten and 9 people coming to dinner. Yeah, you're getting a y-intercept of 0 there also. Which tells me that this graph passes through the origin. Nice. So what about vertical asymptotes? You know, if you do x squared plus 9 equals 0, and then x squared equals negative 9, and you take the square root, if you're awake, you say, oh, that's not a real solution, so I don't have any real vertical asymptotes from my graph. And the horizontal asymptote, because this is first degree and this is second degree, we know that y equals 0 is our horizontal asymptote. So there's our horizontal asymptote. There's our point, and that's all I've got. It feels a little thin. So let's try something over here like 1 and something over here like negative 1. If I plug in a 1, I get 1 over 1 plus 9, or 1 over 10. So I get this 1/10. And if I plug a negative 1 in, I have a negative 1 here. I still have 1 plus 9 is 10. So down here, I have negative 1, negative 1/10. Now, my graph has to approach these horizontal asymptotes. So even though it looks like I'm doing this kind of thing and tempted to keep going this way, I've got to bend back down. I've got to come and approach that asymptote. Okay? Number 9. Number 9 says f of x equals 2x plus 1 over x squared plus 4. So x-intercept, negative 1/2. Y-intercept, 1/4. I mean, I'm just literally plugging in zeros and seeing that fraction. No vertical asymptotes. No. Think about it. Think about it graphically. 0, 4, right? This is the parabola. If you're looking for vertical asymptotes, you're setting that equal to 0 and finding out when that equals 0. Does this graph ever cross the 0 line? No. And the degree here is smaller on top than on the bottom, so again, y equals 0. Okay? X-intercept at negative 1/2, y-intercept at 1/4, horizontal asymptote at y equals 0. And there's my graph. Okay, 10. Ooh, 10, we have to do some factoring. X squared minus x minus 6 over x minus 2. Okay, so that's going to be x minus 3, x plus 2, over x minus 2. All right, I thought maybe this would be a whole, but these aren't the same factors, so we're not going to be doing that canceling there. We do have two x-intercepts. One of them is at 3, the other at negative 2. We have a vertical asymptote at x equals 2. My y-intercept comes from setting all the x's equal to 0. Negative 6 over negative 2 is positive 3. And what about horizontal asymptote? Well, my degree here is bigger than my degree here. So I do have to do some long division. I mean, I guess you could use synthetic. Minus x minus 6. X minus 2x. Don't forget you're subtracting. And plus 1. So there's my slant asymptote. I usually find it helpful to graph the slant asymptote first. Negative 1, 1. We've got x-intercepts at negative 2 and at positive 3. We have a y-intercept at 3. That's up here. And a vertical asymptote at x equals 2. Okay, so my graph then is going to bend to those asymptotes, and my graph is going to bend to those asymptotes. All right, 11. 11 says f of x equals x squared minus 5x plus 6 over x minus 1. So this numerator factors as x minus 2, x minus 3, and we're over x minus 1. Looks like my vertical asymptote is at 1, and I have these x-intercepts at 2 and at 3. Wow, what's happening there? X equals 1, 2, and 3. The degree here is bigger than the degree here, so I'm going to need to do some long division. X squared minus 5x plus 6, and what do I multiply this by to turn into that? Get x squared minus x, and I subtract minus 4x. What do I multiply this by to turn it into this? A negative 4. So, yeah, that line, that's important, and I really do find it very helpful to graph slant asymptote first. Okay, so this is negative 4, this is positive 4, I have an intercept of 3, I have an intercept of 2. I have a vertical asymptote at x equals 1. We see a y-intercept at -6. And now I think I have enough information to draw my graph. It all makes sense to me now. I'm coming down and bending to the asymptotes and passing through those two x-intercepts. And here, coming up and bending to the asymptotes. All done. All right, 12. Ooh, some GCF factoring up top. 12. F of x equals x to the third minus x squared over x minus 1. So when I factor up there, take out that x squared. Oh, look at that. There's a hole at x equals 1. And what I'm supposed to graph is this. Oh, that's great. I know how to graph that. 0, 0, -1, 1, except we have a hole at +1. So right here, there's a hole. That's my graph. Kind of cool. Yes, you're right. Our slant asymptote isn't a line like it almost always is. It's a parabola. And yes, you can have those. Look, that's a third degree. That's a first degree. When I divide the third degree by the first degree, I get a second degree left over. Yep. Stranger things happen every day on planet Earth. All right, let's take a look at problem 13, where we have h of x equals x plus 2 over x squared minus 4. Well, that's a difference of squares. X minus 2. X plus 2, ooh, look at that. And so really I'm only graphing 1 over x minus 2. 1 over x minus 2 has a vertical asymptote at x equals 2. Don't forget though, at -2, we have a hole. I do see a y-intercept of -1/2. -1/2. And since the degree of the top is smaller than the degree of the bottom, I have a horizontal asymptote at y equals 0. So my graph is going to go like that and bend to the asymptotes. But over here, at -2, we're going to have a hole. Over here, yeah, I don't know. Is it up here? Is it down here? I'm thinking it's up here, but I'm going to test a point just to be sure. 3 plus 2 is 5. 3 squared is 9. 9 minus 4 is 5. 5 over 5 is 1. And so we get 3, 1. And therefore our graph looks like that. Okay. That was 13. How about 14? Does 14 have any holes? I don't think so. How did I know that? Even if I factor that denominator, I don't see any common factors on top and bottom to cancel. So mine just has these two vertical asymptotes, one at -2, one at +2. We've got an x-intercept at 1. We've got a y-intercept at +1/4. What else do we need? Well, this says x to the first, this says x to the second. And so we have y equals 0 for our horizontal asymptote. I'm pretty confident that my graph is going to go like that. And if you're less confident, you could do some test point over here. I'm going to save my test point energy to figure out if my graph is here or here, to figure out if my graph is here or here. So I'll plug a 3 in here. 3 minus 1 is 2. 3 squared is 9, minus 4 is 5. So I have 2 over 5. That's a positive value. And so my graph is going to go like that. What happens over here at -3? -3 minus 1 is -4. And on the bottom, -3 times -3 is still +9, minus 4 is 5. And so I get this point down here, -3 negative 4/5. Ta-da! Done. Okay, 15. What's 15 look like? 15 says f of x equals x plus 3 over x squared minus 1, which is the same as x plus 3, x minus 1, x plus 1. So we've got an x-intercept at negative 3. We have vertical asymptotes at x equals plus and minus 1. We have a y-intercept that we can see right here of negative 3. And our horizontal asymptote, because the degree up here is smaller than the degree down here, is y equals 0. So let's graph what we know. And a vertical asymptote, and a vertical asymptote, and a y-intercept, and an x-intercept. Negative 3 is over here. Can I have this shape? No, that requires 2 more x-intercepts. How about this one? No, that requires another x-intercept. No, that requires another x-intercept. The only thing I can do is that. Now, again, like we said before, this could actually look like that. And I'm willing to sacrifice our precision and correctness on that, because really we're just looking for some quick graphs to get us an idea of what's going on. Yeah, I mean, if your mom's life depended on it, you might want to plot some more test points. But by the time we know calculus, we'll have a nice calculus-y way of figuring out what this graph looks like very, very precisely. But in this century, we could also just graph it on our calculator. Okay, so that's 1. I want to plot 2. That's negative 3. I'm going to plot negative 2. If I plug a 2 in there, 2 plus 3 is 5. 2 squared is 4. 4 minus 1 is 3. 5 over 3 is up here, not below. Those would be negative numbers. So I've got 5 over 3. And over here, well, remember, we've got 2 options. We've got this option, but we could also have this option. So depending on whether my result from testing negative 2 is a positive number, I'll get this. If my result of plugging in a negative 2 is a negative number, I'll get that. I find it useful to pre-think about this stuff rather than just sort of, stumbling forward and hoping I get something good to look at. So negative 2 plus 3 is 1. Negative 2 times negative 2 is 4. 4 minus 1 is 3. So I get positive over positive, which is positive, which means my graph looks like that. There's negative 3, and here's negative 2, 1, 3. Okie doke, there's number 15. How about 16? 16 says, do some factoring. We've got y equals to x plus 1, x plus 1. The bottom we've got 2x, x, 2, 1, minus, plus. Ooh, there's a hole at x equals negative 1/2. There's a vertical asymptote at 2. There's an x-intercept at negative 1. And our y-intercept is negative 2. So let's graph what we know. Here's x equals 2, our vertical asymptote. My x-intercept is at negative 1. My y-intercept is at negative 2. Horizontal asymptote, oh look, the degrees are the same. And so we're just going to have 1 over 1, or y equals 1 for our horizontal asymptote. So my graph bends, and don't forget, at negative 1/2, we need a hole. If I plug in a positive 3 into this what's left, I mean, you can plug it into the original, but let's just plug it into what's left over. 3 minus 2 is 1 on the bottom. 3 plus 1 is 4 on the top. 4 over 1 is 4. Is that above our horizontal asymptote or below? it's above 3, 4, and bend. There we go. That's 16. And what about 17? 17, ooh, more factoring. 17 says 3x, x, 2, and 1, and minus, and minus. And on the bottom, we have 3x and x. We have 2 and 1, and we have minus and plus. So these cancel, leaving me a whole at x equals 2. We know our x-intercept is at 1/3. Our vertical asymptote, when I set this equals 0, is negative 1/3. Our horizontal asymptote, because the degrees are the same, is going to be 3/3, or y equals 1. Do I need anything else? How about a y-intercept? If I plug zeros in for these, I get negative 1/1, which is negative 1. So vertical asymptote here at negative 1/3, horizontal asymptote at y equals 1, x-intercept of 1/3, y-intercept of negative 1, and, I seem to be bending to these asymptotes. I know that there's some graph to the left of the vertical asymptote. Well, how am I going to find it? Let's plug in a test point. If my plugging in a negative 1 gives me something bigger than my horizontal asymptote at y equals 1, then I know my graph goes up here. If I plug in a negative 1 and I get a number that's lower than that horizontal asymptote, the graph should go down here. However, ours only has one x-intercept, and we've already used it. So I'm really thinking that what we're about to see looks like this. And at negative 1, I'm going to have negative 4 on top. Negative 3 plus 1 is negative 2 on the bottom. Negative 4 divided by negative 2, positive 2. And that's definitely above our horizontal asymptote, y equals 1. Am I done? No. Why not? Because you didn't put the hole in the graph. At 2, there's a hole in our graph. All right? Please make sure your holes are obvious, labeled, and evident when you do this. All right, 2 more. Oh, we've got some factoring to do here. X plus 3, x plus 2 over x plus 2. And this is problem 18. Oops, these cancel. And so really all I have to graph is the line y equals x plus 3. Don't forget, there's a hole at x equals negative 2. So I'm graphing y equals x plus 3. If I plug in, what is my x-intercept here? It's negative 3. This is 0, 3, by the way. And our hole occurs not at negative 3, but at negative 2. So here's negative 2, and there's our hole. Any questions about that? Well, look at 19. It says, did I graph 18 wrong? I got a slant asymptote, right, because the degree on the top is bigger than the degree on the bottom. And if I do the long division to find this, x plus 2, x squared plus 5x plus 6. And I better multiply that by x and subtract. And then what do I multiply this by to turn it to this? Hey, look, I get x plus 3. Why, that's the same as what's left over. So that's going to happen from time to time, that your slant asymptote and what you have left over to graph are the same thing. And all that means is your function is actually sitting exactly on top of the slant asymptote, and you could only see it by looking through that little hole. But since the hole takes up absolutely no space, you can't look through it. But if you could peel back our function, you would see the dotted line of our slant asymptote underneath. All right, well, I hope that was helpful, and I look forward to seeing you in our next video. Take care, everyone.